Question D6. This is from my student in Reflex. That is his exercise paper. I read the question. A toy rocket consists of a plastic bottle which is partially filled with water. The space above the water contains compressed air as is shown in the figure below. You see on the picture, the compressed air will push the water down, then the toy rocket will move up. Question A. At one instant, during the vertical flight of the rocket, the water of density ρ is forced through the nozzle at radius r at a speed v relative to the nozzle. Determine in terms of ρ, r, and v. Part 1. The mass of water ejected per unit time from the nozzle. That is easy. A. Part 2. The rate of change of momentum of the water. Very simple. But before we answer, I need to revise certain formula that we learned in secondary school. Volume of cylinder, don't forget, volume equals to pi r square h. R is the radius, yes, h is the height of the cylinder. That one I think most of you remember. Number 2, mass equals to volume times density, right? Sec 4 physics. Momentum is, the symbol of momentum is P, and the formula is mass times velocity. And number 4, we need to use a little bit of differentiation. I think, this one I remember, this is called product rule, right? Y equals to U times V, then dy dx is equals to du dx v plus dv dx u. We need to use that later. Okay, first, the nozzle, we assume the water that is coming out is in the shape of a cylinder. It will come out like this, which is not true, of course. The water will spray to the left and right, but we assume is 100% vertical, is the water will never spread out. Then the volume of water, we use the formula V equals to pi r square h. The height of the cylinder we do not know, depends on the time. We take the time to be 1 second. If time is 1 second, then the height will be V times 1. That means in 1 second, the volume will be pi r square V. That's the volume. Then the mass will be ρ, which is density, ρ times volume. This V is volume, by the way. It's not velocity. P ρ times volume. So if you multiply that, you get pi r square V ρ. Pi r square V ρ. Then dm dt you divide by the time, and don't forget time is 1 second because we take 1 second. Then dm dt equals to pi r square V ρ, same as the mass because we just divide by 1. Then the momentum, mass times velocity. Then they ask for the rate of change of momentum. they specifically mention rate of change of momentum of the water. Rate of change of momentum. Okay, this one we call it rate of change of momentum equals to dp/dt. Then we apply the product rule. Very simple. How to apply the product rule? How to apply the product rule? The mass, you differentiate in one term, then you keep it on another term. Velocity is you keep it on one first term and you differentiate on the second term. So dp/dt equals to dm dt times v plus dv/dt times m. Then this dv/dt here will be 0. This thing is 0. The reason is velocity is constant. If something is constant, then the rate of change of that is 0. How do you know that the velocity is constant? I think they mentioned in the question here. Yeah. They mentioned, where is it? Speed v here. Yeah. At speed v. The speed is constant. Yeah. So dv/dt is 0. Then you simplify. Dm dt plus v. Dm dt is this part. From the previous calculation. If you simplify, if you pi r square v square rho. Yeah? Pi r square v square rho. So that's the answer for part A. Then part B. Hence show that the accelerating force acting on the rocket is given by the expression F equals to pi r square rho v square mg. Oh, very simple. Very simple. For question B, we just draw the toy rocket like this. Two forces acting on it. We just call it F1, let's say. F1 is the force pushing it up, is pi r square rho v square from our previous answer. Then there is there's a downward force called mg, which is the weight. Yes, accelerating force at the instant. So the m is changing, so it's a variable. Then the resultant force is just you minus away pi r square rho v square minus mg. That's very simple. Okay. Question C is a theoretical question. I read the question. The toy manufacturer recommends that the rocket should contain about 550 cm3 of water before takeoff. If the initial air pressure is 1.6 times 10 power 5 Pascal, so 1.6 times the atmospheric pressure, all of this water will be expelled and the pressure is just reduced to atmospheric pressure as the loss of water expelled. However, on one flight, the initial volume of water is 750 cm3. but the initial air pressure was still 1.6 times 10 power 5. State without calculation, but with the reason, the effect of this increased volume of water on the initial thrust. This is very simple. F equals to pi r square through v square. F1 here, F1, which is the thrust only, not the resultant. Then it will be equal, no change. Because the velocity and the radius and the density of water never change. The initial acceleration, the initial resultant acceleration, it will change because F equals to pi r square rho v square minus mg. You have a bigger m. This one increase. The increase in m will decrease here. Will decrease the resultant force. Yeah, and it will decrease the acceleration also, right? It will confirm it will decrease. Final mass of the rocket and its content. The final mass will be increased. Very simple explanation. Because at the end, after the pressure become 180 m, there is still extra. How much that? 750 minus 550. There is still extra 200 cm cube of water, which is around 200 gram of water. So it's a theoretical question, and it's you get a good mark. It's 6 mark. Compared with the previous question, you have calculation. They don't give so much mark on that. Yeah. So that is question D6. Your chapter 3. Yeah, chapter 3. I think about forces or dynamics, including the collision. Yeah. Okay. Start with question D1. Discussion 1. Suppose you were seated in a car in which a plumb line, and plumb line is a string with a bob, was hanging from the roof. Sketch how you expect the plumb line to incline, if it does, in the following scenarios. Okay, question A. The car was accelerating at a constant rate in the positive x direction. So I already draw. Yeah, I will draw. I will draw the sketching the plumb line here. And D1A, we assume the positive x-axis is to the right. Then, what is our conclusion? Our conclusion here. Okay, I think I draw from the very start. First of all, the resultant force will be pointing to the right. And remember, when we draw the resultant, must be two arrows like this. Yeah. See, I draw two arrows, and it's pointing to the right, which means after we combine all the forces, it must point to the right. There are two forces. One is the weight, and number two is the tension, because it's a string with a pop. The one that confirm you know the direction is the weight. Yeah, the weight is pointing down. Confirm. Now, there are two possible ways of the tension. One of them is wrong. This is T or T here. Option A is pointing to the left. Option B is pointing to the right. Which one is correct? A is wrong. Why A is wrong? Because if you draw that, the resultant will be pointing to the left. So that's why A is wrong. The correct one will be B. Because if you find resultant, it will be pointing to right. So B is correct. Right? So we erase A. That's how you draw sketch the diagram, right? Weight and tension. How do we know we have weight? First of all, it's a pendulum bob, and whenever they don't mention anything, assume it's on Earth with G equals to 9.81. How do we know we have tension? Very simple. As long as you have a string pointed to a certain object, then you have tension. There is no friction, and there is no normal because it's not in contact with the surface. Very simple. How about B? The car was decelerating at a constant rate in the positive x direction. Again, we assume the positive x to be to the right, and decelerating. What does it mean? Simply means the acceleration is to the left. Very simple. Your resultant must be pointing to the left. Yes. See, I draw the resultant must be pointing to the left. Okay, the resultant pointing to the left because the acceleration is pointing to the left also. The weight is confirmed going down. Tension must be slant up and slightly to the left. Otherwise, the resultant won't be to the left. Very simple. Question C. D1C, the car was traveling at a constant velocity in the negative x direction. Wow, constant velocity. Constant velocity is a very important keyword, right? We are trained to be sensitive to this word of constant velocity. Constant velocity simply means the resultant force is zero. I write on that this is due to because it's constant velocity. The resultant force is zero. That means it's not positive x-axis is here to the right. Positive x-axis is to the right. The resultant force is zero, so it's just vertical. Weight and tension will be equal. They cancel each other. That's why the resultant is zero. So very easy to draw. D1D. The car was driven at a constant speed along a roundabout of which the center of curvature is to the right of the driver. I think you know how it works. Okay. The car is traveling this way, and this is called the center of rotation. Then it's pointing to the right, so positive x is this way. Okay. No, you don't call it positive x, but it's pointing to the right. Yeah. Then your resultant must be pointing to the right like this with two arrows, and that is because that is happening because your tension is slanting to the right, so that's why the resultant is to the right. So that's it. That's question D1. Please check the next video. I think I'm going to explain more of the question we did last Saturday. Last Saturday was very productive. We did 10. No, 10 we skip one. So we did 9. Yeah. Okay. Please check out my next video. Okay, now we do question D2. A man of mass 80 kg is falling vertically. He opens his parachute and experiences an upward acceleration. Upward. That's very important, upward. It seems strange for some people why the acceleration is upward. That is because the parachute make the man decelerate downwards, so it's accelerating upwards. Yeah, the acceleration is 2.4 meter per second square. The mass of the parachute is 5 kg. What is the value of the upward force exerted on the parachute by air? Okay. Okay, what we do now, we have two objects, parachute and man. The first free body that we are going to consider is both of them, parachute plus man. There are three forces acting here. The tension here, you don't have tension because it's within the free body. So you have three forces. Number one is the uplift. Number one is uplift of the parachute. Number two is the weight of the parachute. Number three is weight of the man. So we have three forces: uplift pointing up, weight of parachute pointing down, weight of man is also pointing down. Very simple. They mention the mass of the parachute, which is 5 grams, and the weight of the mass of the man is 80. The one that we do not know is the uplift. So we are trying to calculate the uplift, even though they don't ask, because we needed to find the second. They ask for question A, upward force. That means they ask for U. They give the mass 85, no problem. You can easily tell from here. So the total mass is 85 kg. Yeah, 85 kg. Acceleration is 2.4. So these two information we get it from the question. 85 and 2.4. Then from there we calculate here F equals to ma, right? 85 times 2.4, I get 204. So what is your conclusion? U minus Wp minus Wm is equals to 204, because this whole thing is the resultant. So what is your conclusion? U is equals to 204 plus Wp plus Wm, which is 204. Weight of parachute is 5g, and weight of man is 80g. Yeah, so 204 plus 85g. G is 9.81, of course, right? Then we calculate the uplift. If you press calculator, we get 103.85 Newton. Then this number we need it for the next one. No, we don't need it actually. Yeah, for the next question. So the uplift we get 103.137.85. For question B, what is the value of upward force exerted by the parachute on man? Very simple. We do the man only, which means the mass you put 80 kg, and acceleration is 2.4 meter per second square. How do we get it? From the question, right? The question they mentioned already. Yeah, 80 and 2.4 is from the question, and if you use calculator, you get 192 Newton, the resultant. So this is resultant. Which means, and there are two forces only. Normal from parachute and the weight of man. Free body number 2 is man only. Yeah. So normal minus Wm is equals to 192. So normal will be 192 plus Wm, which is 192 plus 80g, and g is 9.81, of course. Then you sub in the values, you get 976.8. The unit is, of course, Newton. That's our final answer. That's the answer, right? So we have these two. That's the trick, right? To solve this problem, you need to split up into two free body. Free body number 1 is man plus parachute. Free body number 2 is man only without the parachute. Okay, that's for question D2. Quite simple.